In the world of AI, there's always been this one simple rule: bigger is better. But what if that's not the whole story? What if a smaller, way smarter model could actually outthink the giants? Today, we're diving into the story of MiMo 7B, an AI that is seriously rewriting the rules of the game. And that really gets to the heart of what we're talking about today. Can you actually pack the reasoning power of a massive, super expensive AI into a package that's way smaller and more efficient? The team behind MiMo 7B, well, they bet they could. And honestly, the results are pretty stunning. So let's break down exactly how they pulled it off. All right, so here's how we're going to break it all down. First, we'll talk about the big challenge that all AI developers are facing. Then we'll meet our hero, MiMo. We're going to unpack its two secret weapons, being born smarter and taught tougher. After that is showdown time. We'll see how it stacks up against the big guys. And finally, we'll get into why this breakthrough is such a massive deal. Okay, so first things first, let's really set the stage here. For years, the AI world has been stuck on this one simple but kind of frustrating principle. If you want more brain power, you just need a bigger brain. And that has led to this major trade-off. So you've got these two camps, right? On one side, you have these gigantic large language models. And yeah, they have absolutely elite reasoning skills. They can solve insane math and coding problems. The problem? They are unbelievably expensive to build and run. We're talking massive data centers. Then, on the other side, you have the small models. They're efficient, anyone can access them, and they're way cheaper. But the catch has always been, they just don't have that same firepower for complex thinking. So you had to choose, do you want power or do you want efficiency? But what if you didn't have to choose? What if you could get the best of both worlds? Well, that is the entire promise of a new model that's trying to completely shatter that trade-off. Let's meet our reasoning prodigy. This is MiMo 7B. Now, that 7B stands for 7 billion parameters. And you can kind of think of parameters as all the little knobs and dials an AI has to learn from. And while 7 billion sounds like a lot, it is tiny compared to the giants that have over 1 trillion. But what really makes MiMo special isn't its size, it's its mission. It was designed from the ground up, from day one, to be a reasoning machine. And this quote from the creators, man, it just says it all. They call it a model born for reasoning. This wasn't some happy accident or a side effect. Its incredible ability was meticulously planned from its digital DNA, all the way through its childhood learning phase, which we call pre-training, and its later specialized education, or post-training. So how in the world do you raise an AI to be a genius? Well, it all starts at birth, during that pre-training phase. Let's take a look at the diet MiMo was fed. So the first thing you have to wrap your head around is just the insane scale. MiMo was pre-trained on 25 trillion tokens of data. A token is basically just a piece of a word, so, that's just a mind-boggling amount of information. But here is the critical point. It was never just about the quantity. It was never just about throwing more and more data at it. The team behind MiMo curated this data to be incredibly rich with reasoning patterns. Think about it this way. Instead of giving a kid every single book ever written, you give them a hand-picked library of the best science texts, the hardest logic puzzles, and the most elegant math proofs. You're optimizing for quality, not just volume. And the way they did it was super smart. It was this 3-stage approach. First, they built a really broad foundation of knowledge using stuff from all over: web pages, books, academic papers. Then, for stage 2, they started to specialize, cranking the data mix up so that about 70% of it was pure math and code. And then finally, to really get to that mastery level, they added custom-made synthetic reasoning problems and basically expanded the model's working memory. So MiMo was basically born with this brilliant foundation. It had a huge head start, but to become a true elite performer, it needed a special kind of coaching. And that's where the post-training comes in. Honestly, the best way to think about this is like leveling up in a really tough video game. You don't just get points for beating the final boss, right? You get experience points for beating all the smaller enemies along the way. It keeps you going, helps you level up bit by bit. MiMo's training used almost the exact same idea. So the actual technique they cooked up is called Test Difficulty-Driven Reward, and it was inspired by real-world programming competitions. Instead of a problem just being pass or fail, it's broken down into smaller pieces: easy, medium, and hard. So MiMo gets partial credit for solving the easy parts, even if it totally fails on the hardest part. This gives it this constant stream of positive feedback that guides its learning so much more effectively. It avoids that all-or-nothing problem, where an AI can just get stuck and give up. Okay, so we've got a model that was born smarter and taught tougher. It sounds great on paper, but does any of this actually work in the real world? Well, it's time for the showdown. This is the moment of truth. This is where we separate the hype from the reality. Enough talk, let's see the numbers. Okay, so check out this chart, because this is really fascinating. What you're seeing here is the raw, untapped reasoning potential of different base models. This is before they even get their final intensive training. Just find the orange line. That's our MiMo 7B. Look at how it just skyrockets above everyone else. It's even beating the green line, which is a much, much larger 32 billion parameter model. This just proves that its special pre-training gave it a colossal head start. Its foundation was just built different. And then, after the final training, oh man, the results get even crazier. We're looking at two incredibly difficult tests here, one for advanced math and one for code generation. And on both, the fully trained MiMo 7B straight up outperforms OpenAI's O1 Mini, which is a model built specifically for this kind of reasoning. So even though it's a smaller model, that specialized training paid off big time, letting it punch way, way above its weight class. Okay, so this is obviously a massive technical achievement, but what does it actually mean for you, for me, for the rest of us? Why is a smaller, smarter AI such a big deal? So why should you care about all this? Well, it's a huge deal because MiMo 7B could represent a real paradigm shift. First, it democratizes AI. It makes this kind of elite reasoning power accessible to everyone, not just companies with billion-dollar budgets for giant data centers. That means lower costs, less energy use, and it opens up these incredible new possibilities, like maybe having a powerful AI like this run right on your phone or laptop one day. But really, the biggest thing is it provides a new blueprint. It proves that the future of AI isn't just about building bigger, it's about building smart. And that really leaves us with this one kind of mind-blowing question. We just saw a 7 billion parameter model go head-to-head with the industry's best and win. If intelligent design can actually beat brute force at this scale, what else is possible? What could the next generation of small, hyper-efficient, and truly brilliant AI models do? The age of the AI giants might not be over, but the rise of the smart, small models has absolutely begun. Thanks for tuning in.